All right. So this is the agenda that I had for today. I thought we would write the summary for the probability notes. I wanted to know if you had any questions, and then we would go over the probability of independent and dependent events. So there we go. There's our last person. So these notes were posted to Edmodo last night. So hopefully you've printed those and you have your calculator handy if we need to do any calculations or find buttons on the calculator. Also, homework, I posted that, I don't remember when, but it's up now. And then, so that's where we'll start. Does that make sense? Sound reasonable?
Yeah.
Yep.
Okay, so these are the notes. Were these notes okay? Do we have questions about that? Do we want to go over any questions from the notes, or that all made sense?
I think we're good.
Okay.
I think that makes sense.
Yeah, it was okay. All right, great. Where'd you go? You got to stop shaking the table. All right, so I have to write on a separate sheet of paper because I only have one copy of the notes. So, all right. So essential question 36 said, what is probability and what is the range of possible answers for a probability question? So probability measures the likelihood of an event or events to occur. So the way that we measure that is the probability of the event. So these are the number of outcomes. Can I use the hashtag symbol, or does it not mean that for you guys? I'll say number of outcomes in the event compared to the total number of outcomes possible. Is that less glary? I don't know. And the range of possible answers would be 0 is less than or equal to the probability of the event, which is less than or equal to 1. So the 0 means that thing is definitely not going to happen. 1 means that is the only thing that can happen. And any number in between 0 and 1 is a reasonable response for a probability question. If I ask you the probability of something and you say 17 million, somehow we miscommunicated. You should check your answer. Are we ready for number 37?
Yeah.
Okay, so 37. This one, what cards are in a standard deck of 52 playing cards? So in a standard deck, so we've got 2 red suits. So we've got hearts and we've got diamonds. I am just, and then we've got spades. And we've got clubs. Which is the best I've drawn those two all day. So for each, so we've got 2 red and 2 black, and all of them have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So that's the 13 cards for each one. So that's Are we okay with that one?
Yeah.
Okay. So number 38 says, how many possible outcomes are there for 2 6-sided die? So there are 36 outcomes. And 39 says, what is the probability of the complement? How are we feeling about that? Comfortable, not comfortable?
That's kind of like the hardest part for me.
Yeah.
So,
So embellish my answer.
yeah.
Okay. So, so the probability of the complement Okay, so I've written down the probability of the complement. So that's the probability of the complement of the event equals 1 minus the probability of the event. So the complement of the event and the event have to be mutually exclusive for this 1 minus all the other outcomes to work. So does that make sense? And it's okay, you can say no, it doesn't make sense.
It makes sense to me.
That's
Could you explain
okay?
it a little more, please?
I'm sorry, say again?
Could you explain it a little, please?
Yeah, so I'm going to talk about it using geometry terms. So, you know, in geometry, this is a 90-degree angle. And
Mhm.
if I've got this angle is A and this angle is B, because they add up to 90 degrees, they're complements.
Mm-hmm.
Right? Okay, so if I tell you how much angle A is, let's say it's, I don't know, let's say this is 43 degrees.
Mm-hmm.
Can you tell me angle B?
Yes.
And how did you find it?
You would do 90 minus 43.
Yes. Because it's the complement,
Mm-hmm.
right? So when we say
Oh.
complementary angles, 90 is the largest it can possibly be, right?
Uh-huh.
So when we say complementary events, 100%, that's the only thing that can happen is the largest value for a probability.
Oh.
So when we
Okay.
say 1 minus, however many ways this stuff, the probability of this could happen, that's how we get the value for this part.
Oh, I see. Okay, thank you.
That makes more sense?
Yes. Thank
Okay.
you.
You're welcome. Other questions about the summary? Okay, so do we have questions about the homework? I mean, if we're a little bit not super confident about the complement, then maybe we should look at number 14 in the homework.
Yeah, can we maybe do like a couple questions that might be
Yeah.
like, so we need, yeah.
Do we want just questions specifically about the complement? Or did you have other questions on here? You can't hurt my feelings.
I think, I don't know, probably like mostly like just the compliment, but
Okay.
I don't know if anybody else wants the other ones, but
Okay.
Yeah.
Anybody else have opinions?
Just compliment.
Just the complement?
Yeah.
Okay. And we can add to it if we. So should we do number 14 or should we do one like 14?
can we do one like 14?
Sure. All right, so similar to 14. So if two six-sided die are rolled, should this be die or dice? It has been annoying me all day. I'm gonna have to email Miss K and find out. Any honors English people in here have an easy answer for me?
I'm honestly not too sure, but
I know, but if you say two, my husband's helping me. So if you say two six-sided die, we say dice then? He's pretty confident it's dice. Okay.
I think it might be dice since you're saying that they're like two.
Oh, okay.
Dice.
My Dungeons and Dragons husband says for sure it's dice. Okay.
Okay.
If two six-sided dice are rolled, what is the probability the sum? Do we want to do the sum? The sum
Yeah.
is greater than 5.
We would need the chart for this, right? Or it would probably be helpful, like the chart that you gave us, like with the 36 different outcomes.
Yeah, that's why I put it in the notes. So we can
Oh.
use use the chart, but also like here, I'll do it without having the chart. I don't know if that will increase your confidence or not, but so the probability, the sum is greater than 5. So that means we could have 1 plus 5, 1 plus 6, 2 plus 4, 2 plus 5, 2 plus 6, right? So we've got 5 things and we haven't even considered what happens with 3s.
Wait, could we go backwards so it'd just be 4 and 1 and 1 and 4 and then 3 and 2 and then 2 and 3?
You totally can if you want to, but I tend to break it down into like, these are the ones, these are the, like I rolled a 1 first and then a 2 first and then 3 first. So
I see.
I just use the same algorithm every time.
Oh, okay.
But you could use something else if you wanted to.
Okay.
Okay, so this is just going to keep going on and on, right? So I think it might be easier here to say 1 minus the probability that the sum is less than or equal to 5. So
Yeah, because then there's less options.
exactly.
Right? Okay.
So if I don't have the chart with me, I would say 1 and 1. I could roll snake eyes. I could roll 1 and 2, 1 and 3, and 1 and 4, right?
Yeah.
Okay, then I could roll 2 and 1, 2 and 2, 2 and 3, right?
Yeah.
Then I can roll 3 and 1, 3 and 2, and then 4 and 1, right?
So 1. Yeah.
So those are the options.
Yeah.
So we've
Okay.
got 1,
makes-
2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 1 minus 10 out of 36.
Minus. Okay.
Does this make sense?
Yeah, that makes sense. And then you just use 36 over 36 minus 30.
Or you could reduce that first because then they're both even.
Mhm.
So we get 26 out of 36.
Yeah, and that would just be the answer, right?
Yeah, so this is the probability that the sum is greater than 5. So does that make sense?
Yeah.
Okay, and keep in mind, you didn't have to do this method. You totally could have come up with all the 26 combinations here. So you could
Oh, so
solve
you
it this way, or you can solve it this way. It just so happens that this way is easier,
yeah.
but
So
you don't have to use that way at all.
you could either just count all of them out, but that would take much longer, or you could just do the equation and then that
Exactly.
just answer quickly.
Exactly. Do we have any other homework questions?
Can we do one more?
Yeah, I think
One more like this one?
Yeah.
Sure. Let's see here. So let's say it's the same situation, and let's say we want let's say the probability the sum is greater than 3. Greater than or equal to 3.
Okay, so like with these questions, like with the complements, will we only be using like 6-sided dice, so like 36, or is there other like examples?
Well, yeah,
of-
we could say 8-sided die, but then you just have more of these things to list out.
Yeah. Okay, so we're just using like dice in general.
Yeah, because I mean, you have never seen this before, right?
No.
Right. So this isn't something we're building off of a foundation you got in Algebra 1. This is we're building
Yeah.
the foundation. So I kind of feel like let's keep it kind of simple,
Yeah, makes sense.
especially considering our circumstances.
Mhm.
But this is what's in the textbook. I'm not watering this down for you. Okay, so do you want to have a go at this on your own, or should we do this together?
Can we do it together?
Yeah, for sure. Okay, so we're assuming we have to find the probability when the sum of 2 6-sided die are rolled, that the sum of the 2 die will be greater than or equal to 3. So
we would, in this case, we could just find like the last question. We could just do what less than or equal to 3, right?
well, so they have to be mutually exclusive. So if I say it could be 3 here, then it can't be 3 here. So what do I want the event to be over here? Ah, okay. So we could have 2, 3, 4, 5, 6, blah, 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 right? 6 plus 6 is 12, right? So those are all the options. So if the sum is greater than or equal to 3, that's all this, right? To here, because that's where it stops for 6-sided die.
Mhm.
Then what's this over here? What do we call that?
Just less than?
Yeah, sum is less than 3.
Oh, would it just be less than 3 or less than or equal to?
No, because I already
Oh,
counted 3 over here.
So it has to be. It can't include that. It has to be exclusive. Okay.
Right.
Okay, that makes sense.
Okay. Are we good? Everybody's good?
Yep.
Okay. So when the sum is going to be less than 3, basically that's snake eyes, right?
Yeah.
Because 2 and 1 would be 3, so that's it. So we've got 1 minus 1 over 36, which is 35 over 36.
Oh, okay. So it's just one option since.
Exactly. There's only one way you could.
Yeah.
could
So if it said like if you just said p is sum is greater than 3, then you'd
Yes.
have to do sum is less than or equal to.
yes.
It has to be like okay.
Yep.
And then it'd be 2 and 1, and then 1 and 2, right?
Exactly. Then there'd be 3
Yeah,
options
3.
there, because
Okay.
1 and 1, 1 and 2, 2 and 1.
Yeah. Okay.
Good. So do we feel more comfortable with that?
Yeah.
Great. Okay. So are we ready for notes?
Yeah.
Yes.
Okay. So here we go. The probability of independent and dependent events. This is from, I'll be done when they're telling me I'm done. Sorry. I could be half an hour. Okay, so this is from section 10.2 in our textbook. The essential question, number 40, how do I know if 2 events are independent? 41, how do I know if 2 events are dependent? And 42, how do I calculate the probability of 2 independent events compared to 2 dependent events? So in the margin here, and I didn't mark these up, so you're welcome to highlight, underline, however you want to. So 2 events are independent when the occurrence of the first event does not impact the, so maybe we want to do independent and does not impact the occurrence of the second event. Contrary, 2 events are dependent when the occurrence of the first event impacts the second event. So you've noticed that these are all story problems. So there will be key phrases or situations described that will let you know if it's independent or dependent. Basically, 2 events are independent if I have a collection of things and I draw something out of that collection and I don't return it and I draw something else. Well, when I drew the second item, there were fewer things available to choose from. So that makes the events dependent. If I have a collection of things, I draw something out and then I put it back before I draw the next thing, they're independent because they had the same quantity of items to choose from for the second drawing. So those
are the events for like last section we compared like it was like the batting order, would that be dependent?
well, so a batting order is not a probability, like how many batting orders.
This is different. Okay.
Yeah, so that's a different kind of situation. But basically here I draw a card. Do I put it back before I draw the next card or do I not?
You don't.
So if I put it back, then they're independent events because there's still 52 cards in the deck.
Mm-hmm.
If I don't put it back, then they're dependent events because now I only have 51 options to choose from.
Yeah. Okay.
So that's the kind of language we'll be looking for. So we will be multiplying the probabilities of each event together to find the probability of both events. So we'll be using multiplication here, similar to the fundamental counting principle. Okay, so here are our examples. So 10.2, example 3. As part of a game, you need to spin a spinner. It's got 8 equal sections labeled 1 through 8. What is the probability that you get a 5 on your first spin and you spin a number greater than 3 on your second turn? So we've got, I've got 3 directions here. First of all, I want you to identify the events. Secondly, I want you to tell me if they're independent or dependent and how do you know? And the last thing I want is to find the probability and, you know, check your answers again. So part A says the first event is spinning a 5. So I've just called that P out of 5. The second event is spinning a 3, greater than 3. So I said the probability of greater than 3. So keep in mind, there's only 1 5 on the spinner, so that would be 1 out of 8. Keep in mind, if you spin it greater than 3, that could be a 4, a 5, a 6, a 7, or an 8. So that's 5 out of 8 options in this case. So part B says these events are independent because the first spin doesn't change the options on the wheel, right? So on the board game, you spin and then you spin again and nothing's been taken off. So we've got the probability of spinning a 5 and then greater than 3. So we're going to break those apart into their individual events and multiply them together. So we've got 1 out of 8 times 5 out of 8, because again, there's 1 5 out of the 8 sections. And there's 5 options, the 4, 5, 6, 7, and 8 out of the 8 segments on the wheel. And so we've got that multiplies to 5 out of 64. Again, this is a number between 0 and 1, so there's no reason to think we've calculated that incorrectly. Questions about that one?
No, that's good.
That's good.
All right. So 10.2 example 4 says a bag contains 20 $1 bills and 5 $100 bills, and you randomly draw a bill from the bag, set it aside, so that's important, then randomly draw another bill from the bag. What is the probability that both bills are $100? So again, we'll identify the events. We will determine if they're independent or dependent and justify our reasoning, and then we'll find the probability. So the first event is drawing a $100 bill. So I've denoted that P of $100. And the second event is also drawing a $100 bill. So the events are dependent because the first bill was not returned to the bag before the second bill was chosen. So that's how we know it's dependent. So there's fewer $100 bills to select the second time you draw a bill out. So part C, the probability of drawing a $100 bill and another $100 bill. There were 5 $100 bills initially in the bag, and there were 25 bills total. So 20 of them were $1 bills, 5 of them were 100. So that's how we got the 25. But we didn't put that bill back. So now we've got 4 $100 bills still in the bag, but there's only 24 bills in the bag because we're missing the one we drew first. So I simplified those fractions to get 1/5 and then 1/6, and I multiplied them together to get 1 out of 30. Does that make sense?
Yeah.
Okay. All right, so are we ready for the last example?
Yeah.
Okay. So here is 10.2 example 5. You randomly select 3 cards from a standard deck of 52 cards. What is the probability that all 3 cards are hearts if you replace each card to the deck, shuffle, and then draw the next card? So we have to identify the events, determine if they're independent or dependent, and justify a rationale, and then C, we have to find the probability. So the first event is drawing a heart, that's P of heart. The second event is drawing a heart, that's also P of heart, and the third event is the same. So these events are independent because each card was returned to the deck, shuffled, and then the next card was selected. And then in part, does that make sense?
Yeah. So if it wasn't, like, let's say it was dependent and like you took out the heart, then it'd be 13 out of 52, then 12 out of 51, then
Yes,
11 out of 50.
exactly.
Okay.
Yeah. So the probability of drawing a heart and another heart and another heart, because we're replacing them, we've got 13 out of 52 times 13 out of 52 times 13 out of 52. As Jared was saying, if we draw a heart out and we don't replace it, right? So suppose they're dependent. Then in that case, it would be 13 out of 52 would be the first card drawn. But then we would have 12 out of 51 total cards for the second card, and then 11 out of 50 for the third card. Are we okay with that?
Yeah.
Great. So we ended up with, this all simplifies to 1 out of 4. So when I multiply those together, I get 1 out of 64, which again is a reasonable answer for probability. Questions about that?
No.
Okay, great. Any other math questions? Anything from chapter 8?
Could we maybe do like another example of like of this or of this section? So like we have one more example.
Sure. Let me find one.
We maybe do like a dependent one that's like a little more tricky, or it's like
Okay. Okay. All right, here we go. So this is from the chapter review. So let's say we so let's say we have to find the probability of randomly selecting a red marble then a green marble from a bag of 5 red, 8 green, and 3 blue. Without replacing the red marble. Oh, I guess that's not a question. I guess that's a please do this. So should we try this together? Do you want to try it on your own?
Can we try it together?
Yeah. Does everybody have the question written down or as much of it as you need to write down?
Yeah.
Okay. So we are finding the probability of drawing a red marble and then a green marble. Now, we have said we are not replacing the red marble. Does that tell me it's independent or dependent?
and then
Dependent? That's dependent, right?
That's dependent, yep. Oh. So how many red marbles are there? There's 5 red. How many total marbles are in the bag? 5, 13, 16. Does that make sense?
Mm-hmm.
Okay, and then how many green marbles? There's 8 green, but Now there's only 15 in the bag. Does that make sense?
Yeah.
Yep.
Yeah.
Okay. So I would like simplify this. Does that make sense? So 1/2 times 1/3. So this would be like 1/6. Does that make sense?
Yeah.
Okay. How are we feeling confident about that?
Yeah.
Yeah.
Okay. Do we want another one like that?
Yes, please.
Okay. So same bunch of marbles. Let's say we have to find the probability of drawing a green and then a blue. Now, do you want to try it on your own or should we do this one together?
Yes, I don't know. Try it on our own.
Okay.
And after a little bit, we can like you can write it down, I guess.
Okay, I'll count to 60.
Okay. But can you go back up to the question? So like we have like
The numbers. Is that the right
Yeah.
stuff? So we're assuming without replacing the green.
Okay.
Is this with the red and the green like put back into the?
Yeah, so we're starting with the same bag of marbles. 5 red, 8 green, 3 blue.
Okay.
So I got 1/6 again. Is that what you found?
Yeah.
Okay.
Can 3/15 be 1/5, not 1/3?
Yeah, thanks.
Then it should be. I got
I
110.
knew. I knew. I was like, something doesn't
Yeah.
feel right to me, but Mackenzie said it was okay. So I was like, all right.
Yeah, I was like.
I thought I did it wrong because
Oh,
I
I
got
put it in my calculator wrong.
24 out
There we go.
and then
Yeah, I got 0.
simplified to 110.
So wait, so do we think this is true or do we think it's not true?
I got 1/10. Yeah.
Yeah, 110 is right.
Okay, so we're feeling better about that now. Yeah, I was thinking that was quite a coincidence, but then, yeah. Okay, so are we more comfortable with these or do we have more, we want more examples?
I'm good.
Yeah, I think it's good.
Okay.
Yeah.
All right, cool. Is there any other math questions you have?
No.
Okay, so